So what I have here is a set with 4 elements. So n is equal to 4, and I'm choosing 2 of them, so r is equal to 2. So what I'm doing is I'm counting permutations of 4 objects taken 2 at a time. Well, if I follow the definition up there, it's going to be 4, and then look what happens. I just keep going down. N times n minus 1 times n minus 2, so I would have 4 times 3. And when do I stop? Well, I stop when I get down to n minus r plus 1. N is 4, minus r would be 2, plus 1 would be 3, so I stop. So it's just 4 times 3. So that is equal to 12. So there are 12 different ways to choose 2 objects from that original set of 4 objects. So you stop counting down on multiplication when you get one more than r. Okay. Let me show you another formula that I believe it's in the book, but sometimes people find this one just a little bit easier. Another formula for permutations is this. Permutations of n objects r at a time is equal to n minus r factorial. Whoops, nope, that's wrong. Let me erase that. It is n factorial divided by n minus r factorial. Okay, so if I want to use this formula, I would have permutations of 4 objects taken 2 at a time. I have 4 factorial over 4 minus 2 factorial. And I'm going to show you a little trick you can use if you don't happen to have your calculator. And by the way, I will show you how to use your calculator to calculate permutations with big numbers. There's a permutation function on your calculator that you can always use. But watch this. 4 factorial is equal to 4 times 3 times 2 times 1. 4 minus 2 is 2 factorial. So that's 2 times 1. So like 2 times 1 cancels with 2 times 1 down here, which just leaves a 4 times a 3. So you can always do this little trick. You'll always be able to use the bottom factorial to cancel out a lot, or at least some, of the numbers that are on top. So whenever you're doing this calculation, you'll always be able to do that. And again, I'll show you in class how to use your calculator to do this.